Hi, so today I'm going to be showing you the smart outlets that I've made for my OpenHAB home automation system. Let's take a look. Okay, so what I have here is a custom PCB I ordered from Seed Studio, and this is meant to, I'm utilizing NodeMCU boards, like this one here, and so basically the NodeMCU board will control a relay that is inside of the outlet box that this is going to be housed in. So you have your AC inputs that come into here, and then there's a little mean well regulator there. So the AC inputs go into the top there, and then a regulated 5 volts comes out, and then the 5 volts goes into the VIN pin on the NodeMCU board, and then that powers the whole thing. And then there's 2 pin headers right here, and these are used to control both of the 2 relays inside the outlet box. So one of these pins on each of the headers is hooked up to a pin on the NodeMCU board. So when you pull that pin high, then it'll turn on the relay, and when you pull it low, the relay will be off. So that's how I'm controlling the outlets. And so I have a partially assembled one here. Let me get this into focus. So as you can see, an extension cord comes in through here through a cable gland, and then these wires will be connected into these little Wago connectors here, and so that'll distribute power to the whole thing because this board needs power in addition to the actual outlet, so that's how I'm accomplishing that. And then we'll go ahead and take a look at the code and my OpenHAB configurations. Okay, so right now I have the OpenHAB web user interface open, and I've also SSH'd into the Raspberry Pi, which is running the Mosquito MQTT server. And I've subscribed to all topics using this command so we can see what's happening. So if I activate this switch here on the web user interface, you can see 2 separate commands are posted via MQTT. Now, this is because I designed the outlet so that each individual receptacle is controllable. So they're not both linked to one relay. So there's actually 2 relays inside of there. Now, I obviously want both of the lamps turned on in conjunction with each other. I don't want to have 2 separate switches. So that means I need some additional logic beyond this switch. So if we go into the my OpenHAB rules file here, you can see that right here I've got a proxy switched, or just a dummy switch, which is what you see on the OpenHAB web user interface. Now I've done this because we need to somehow control both of the lamps, which I have here. So I say when the switch, the dummy switch, is received a new command, then switch both of them on or off, depending on the state of the switch. So right here is the sitemap file, which you see the dummy switch, which I've named the proxy switch, which is referred to here in the rules file. And then my .items file, these bottom 2 items are both the lamps. So as you can see, those are both the same commands that we saw posted in the terminal earlier when we were SSH'd into the Raspberry Pi. Now I'm going to talk a little bit more about how I design the outlets and how the electronics work. Now on the right you can see the Raspberry Pi running the OpenHAB server as well as the Mosquito MQTT server. I have the Raspberry Pi connected to my local network via an Ethernet cable to a local switch. On the left is the smart outlet, which contains the 2 relays, the outlet receptacle, and the NodeMCU board. To control the power of the outlets, I am interrupting the live wire that is normally connected directly to the outlet. It is important to always keep the ground connected in case of a short, and it is always best practice to not interrupt the neutral line, but the live instead. In this case, I've split off the live line into 2 separate wires using a Wago connector, and have tied these wires to one of the AC inputs on the relay. The other AC connection on the relay goes to the live input terminals of the outlet. Notice there are 2 live inputs going into the outlet, whereas there's only 1 neutral input. This is because all standard US outlets have a small tab connecting both screw terminals on the side of the outlet. Normally this connection is unbroken so that only 1 wire is needed for the live input. In this case, I have broken the tab, which is how you can control each plug on the receptacle independently. It is possible to use just 1 relay to control both plugs simultaneously, but I prefer the added functionality of being able to control each plug separately from one another. Now we'll take a look at a fully assembled outlet in the real world. Here is a fully assembled outlet. The PCB is located on the bottom where you can see the AC input lines going to the mean-well regulator. The relays are in the back of the outlet stacked on top of one another. One important note is that all metal surfaces are covered in orange craft foam to prevent short circuit of the AC lines of the inputs on the PCB, as well as to provide isolation between the high and low voltages in the outlet. There is also foam in between the two relays since the bottom of them are metal heatsinks. You don't want the AC lines from the bottom relay shorting on the metal plate from the relay above. The top relay also has a piece of foam on top of it that is not pictured here. Since everything is such a tight fit, I opted to use Wago connectors instead of standard wire nuts for distributing the AC lines. The Wago connectors are super easy to use and provide secure clamping pressure on all the wires. I also used ring connectors with all AC connections on the relays and the receptacle itself to ensure all the connections would be secured after everything was scrunched into the box. If you enjoyed this video, please leave a comment below of any future projects you'd like me to tackle. I plan on creating a video soon about a capacitive touch-based wall mount plate that can be replaced with existing manual wall switches in your home. I also plan on creating a video about a garage door opener that works with OpenHAB. Hope to see you back here soon.